Hi, welcome to our Senior Project Design, FPGA Hardware Emulation for the Atari 2600. I'm Carl Clark. I'm currently a full-time student and a part-time intern at Intel.
Hello, my name is Caitlin Blythe. My interest is in digital signal processing and FPGA programming.
Hi, my name is Nick Kasha, and I have 3 years of experience working in digital design and failure analysis.
Hi, my name is Mohammed Sheikh, and I have 3.5 years of experience as a software engineer and machine learning intern at SAIC.
Hello, my name is Kendall Welsh, and I have 10 years of experience repairing electronics in the Navy. The goal of the project is to create an emulation of the 1977 Atari 2600 console using an FPGA by replacing the 3 original integrated circuits with modules written in System Verilog. By using an Altera prototype board, the group will be able to modernize the capabilities while also maintaining the integrity of the original console by using a GPIO header to interface with original hardware such as game cartridges and controllers.
The 6507 and the TIA chips are both fully coded and are undergoing testing and validation. The Riot chip testing is in progress, and issue and testing caused rewrites to happen that are currently ongoing. We currently have all 3 chips instantiated in the main Atari 2600 System Verilog file and are debugging the full file and tracking the data in order to achieve our final integration, as well as confirming the addressing and memory of all chips so that the product functions properly as a whole.
Team has made significant progress in testing the open source 6502 CPU module. So far, 31% of the opcodes have passed verification and validation in ModelSim. Select opcodes are also being prepped for verification and validation on board the DE10 Lite to ensure that all 56 unique instructions for the 6502 are covered. We hope that extensive V&V aids in debugging efforts during chipset integration and interconnection between chips such as the Riot 6507 and TIA.
For our prototypes, while we don't have any single unit, we do have several key progress points met. We've achieved video out from the FPGA via the VGA port. We've interfaced the FPGA with an original game cart via GPIO pins, and we've began integrating all modules together in simulation. These were all tasks that we thought may be breaking points early on, but our success has led us to believe that we'll be successful in the full design. In order to achieve our final build, we are really focused on 2 simultaneous areas: deployment to FPGA and full system debug. Our work on FPGA deployment is meant to reassure us that our CPU core compiles and synthesizes on the FPGA. For our full system, we will continue to focus on debugging and ensuring that all of our modules interface and trade off data correctly. Once we are able to see that data is correctly traded and a game program completes its startup, we'll begin deploying our full design to FPGA and testing at that level.
Our plan for Demo Day is to have our fully operational FPGAtari console and an original Atari 2600 together so that guests can play and compare them side by side. The reason for this is to showcase just how accurate our hardware emulation is. Additionally, we are going to have a visual diagram showcasing the Atari 2600's architecture compared to our digital implementation. By providing this visual diagram, we hope to be able to illustrate to guests the differences between software and hardware emulation and why we chose to do hardware emulation.
The FPGA Atari project has experienced immense progress towards hardware emulation. So far, the team and mentor have assessed that our current progress is in line with our expectation to have a minimal viable product by demo day. We predict that the largest bottleneck will be the integration of our individual chips together into a functioning architecture. This is because this includes arduous tasks such as clock and timing synchronization and debugging at the register level.